Hey everyone, welcome back to my channel where I talk about all things tech and finance. And in this video, I'm going to be going more into depth on data munging or data wrangling. They're somewhat known to be each other, but the majority of your time will actually be spent on cleaning your data. And I'm going to be going over the minimal basics that will get you pretty far in the data process. So even though data munging and data wrangling are sort of synonyms with each other, in my mind, I always associate data munging as the very first process to try to clean your data, and the data wrangling part is the automatic process of cleaning your data. So you use data munging to get to the data wrangling process, where the data wrangling is associated with many functions, and the data wrangling is where you're physically typing away to try and find relationships or maybe even filter your specific observations from your given data set. So note that in the data analytics realm, whether it be the machine learning realm or the visualization side, you are going to be spending the majority of your time working on this process. So expect to be spending maybe 80% of your time just cleaning data, getting the correct information or whatever information that you want to portray to be a part of whatever analytics that you would want to portray to your clients or even to yourself. I'm going to be providing you some pretty advanced tools to use in order to cleanse your data set. And most importantly, when you are using these tools, it's going to be really effective, really efficient, and most importantly, it's going to be pretty readable. So I'm going to be going through all these steps and processes of various functions and packages in order to help you on your way to cleansing data. Okay, so over here, I already loaded in a few libraries. There's going to be a few more libraries down the road, but I'll load them as I see fit. And for this one, applied predictive modeling, there's going to be an abalone data set, so go ahead and install that. I'm using the notorious Carrots, where it's a really neat machine learning library, and I'm going to be using a soybean data set coming from ML Bench. So let's go ahead and start with the abalone data set, and we can load that by stating data abalone, and this is the data set that we will be using. So this is what we're going to be working with. Maybe we want to clean our data so that we are trying to predict rings, which rings in the abalone sense is however many years the abalone is actually living. And maybe we want to convert the type into a one fact or one hot encoding. So this is where the little carrot library comes into play. And all we would do is just name a dummy set, and then dummy vars is going to be a real nice function in order to write a function on itself in order to do the one hot encoding. So we would just do this. This is what the dummy is, and then we will use this dummy, and then we'll just call it like new data. We're going to cast this to a data frame, and we are going to be predicting on itself using the dummy, and then the new data is equal to data. So this is going to be concatenating quite a few observations, and if we were to look at that, we have now one hot encoded features, F, I, and M on itself, and we could go ahead and predict rings without the categorical observations in this way. Okay, so let's go back to our data set, string data. We're not going to be using the original, well, our converted casted data set. We are going to be going ahead and just play around with the apply family over here, and the apply family is actually really powerful. It's basically like you can run various functions in all of your rows or all of your columns, and everything will have that function run on top of it. So incredibly powerful and very efficient and effective. I use it like all the time. So the most basic function you want to be aware of is just the apply. And note that many of the apply functions are pretty much exact same thing, but they just return different variables, like whether it be a list, an array, or a data frame. So in this case, it will be returning a vector or an array of values that are going to be coming on through. So let's go ahead and just apply our data set. Also, since we have a factor in here, to make things easier, let's take out the type. So let's just call this D, and then data to all the way from the columns, all the rows, and then dimensions of data. Give me the columns over here, and our D should be good, so we don't have type anymore. So we're going to be running the apply function on D. So let's go ahead and run it on the columns. So we have to specify margins equal to 2, which is for columns, and margins equal to 1 for rows. And then we just call a function that maybe some built-in function, maybe like sum. We can do that, and then this is the sum for all of the columns pretty neat, really effective. It's basically like column sums, but you can run this on the rows as well. And let's look at the very first row, 16.9045. So let's look at the head of our D data set. And if we were to add all of these observations, I just added a plus sign for each and every one of these observations that we have 16.9045, which is the exact same or what we expected over here for the apply function for the very first row, 16.9045. So change that back to the columns and voila, that's pretty much the apply function right there. So there are different apply functions, as I mentioned earlier. We can take a look at the L apply. And this is basically like very similar, but it just returns a list instead. So let's go ahead and run the L apply function, D event margin is equal to 2, and then function is equal to sum. Let's look at that. Oops, lowercase. Let's run that. So over here, it returns a list. And if we want to view this, let's go ahead and view that. This is what that list will look like. And if we want to view our original apply function, this returns a vector over here. So really neat stuff there. And that's pretty much the L apply function here. And then there's the S apply, which is basically a layered approach to the L apply function. The only thing that is the difference between the two is that for S apply, this will actually go ahead and try to simplify the elements to its most basic format. So if we wanted to apply S apply, and then put the D over here, margin is equal to 2, function is equal to sum, and then the only layer function is going to be the simplify value. And then we put for true, lowercase sum, and then if you wanted to view what format that is going to be in, the most I guess basic format is going to be the vector over here. And if we put that to false, we should get the exact same as what we had earlier for L apply. So that's pretty much the S apply. So you can run a variety of functions or just have, like you can skip a few steps like casting your original data set to as that data frame. You don't really need to do that. And it's really clean and very easily readable once you sort of get the hang of it. And then the last but not least is going to be the M apply function. So this is going to be really cool. This is sort of separate from the typical apply families. Here, the multivariate version of S apply. So a real cool example is that if you're trying to repeat rows or columns instead of using the repetition function, like the rep function over here, you go ahead and do M apply, and then you call the repetition function. Maybe if we want 4 rows, and over here map apply, I'm forgetting the L, so right here, so like number of rows, number of columns. Really cool. That's pretty much all you really need to know for a map apply. It's not really used that much unless you want to go ahead and simulate some data and just create some real easy data sets without utilizing a bunch of steps trying to cast your data set in a certain way. So this is really cool. Maybe if we want to put this to like 2 to 10, voila, that's how you would go about doing that. So that's the map apply function. So yeah, there you have it. That's pretty much all the apply functions that you really need to know. A real common thing is just using margins equal to 2, and then the function is equal to as dot numeric. This is like really I use this all the time. And if we want to just apply the string, so the string variable, so we see the variable type, let's just do L apply over here. Yeah, everything is going to be a numeric. And if you saw earlier, we have an integer over here. Okay, so the very next library is going to be the dplyr library. And this library is incredibly powerful. This is pretty much the go-to library when it comes to cleansing your data set and extracting various information from your data set in order to portray visualizations or machine learning types, or just do some more exploratory data analysis. And so the only thing that's a little bit wonky about the dplyr stuff is that they use pipes, and the entire pipe world is very vast. And I'm not going to be going more into depth on that, but all you really need to know is that you're applying a function onto an object, and that returns another object, and then so on and so forth. And we'll go a little bit more into depth on that. So let's go back to the original data set. where we still have our type, and maybe we just want the type function or the type feature. So all you would do is run the pipe, and then maybe you just want to select the type column over here. Voila, you have all of your rows from that dplyr function. So maybe you want 2 columns. So let's take a look at, maybe you want longest shell. So all you would do is just copy the column name, put in longest shell, and voila, you have 2 features that are extracted. So maybe we want to minimize the output. Let's get the very first 10 rows, and then you just do head of 10. That is like that easy. It's really easily readable, and you don't have to worry about indexing or any of that other nonsense. So maybe we want to filter. So let's go back to the original data set, and then you just use the filter function. So maybe we only want males. So you just do type is equal to m, equals m, sorry. Yes. So these are all the rows that have the value of m. Really simple, real easy to use. It's really powerful, very efficient. Maybe you want to plot some stuff. So let's go back over here and let's just go data, run the data. We want 2 columns so that we can actually plot. So let's go longest shell, and let's go ahead and use diameter. And then let's just run the plot function. Voila, that's like really easy, really cool to use, fast, efficient. So maybe you want to go ahead and maybe do some more, extra stuff. So let's say that we want to extract some observations. Maybe we only want diameter to be greater than 0.3, and then rings to be less than 10, less than 10 rings. And we will only want male abalones over here. So let's go ahead and do that. So run the pipe function, you use the filter, and then you can use a variety of operators. So type equal male over here. And in this case, we're going to be using the AND operator because we want everything to fit this condition. Instead of it being a true and false, we want everything to be true. So let's run the diameter. It has to be greater than 0.3. It's greater than 0.3. And then the other AND operator, say rings is less than 10. And then this is going to be a subsetted form of our condition. So as we can see, all of our rings less than 10. All of our diameter observations greater than 0.3, and as we can see here, the gender is male. So let's move on from this data set and let's load in this soybean data set. These are the observations that we'll be working with. We got factors, we got ordinal factors, so on and so forth. So we can easily go ahead and run functions to get specific strings. Let's get a better view of that. So we can get specific strings from here using the grep function, so on and so forth. So let's go ahead and run that. So it'll be basically the soybean, run the pipe function on that. And so we want to filter. Maybe we only want, it could be brown. Let's get brown. Just the word brown in it. It just needs to have brown. That's, I guess, it. So brown spots and brown stem rot. So let's go ahead and do that. So it'll be just grepple. And then we just run, I think it was like brown. I think it was like lowercase brown or uppercase. I don't remember. Let's look that up. Yep, lowercase brown. So lowercase brown, and then we can run that on the column name, which is class. Let's run that. So we have observations. Yep, brown spot, brown stem rod. So it's basically like a real nice regex function if you want to run on that. And maybe you don't want the word brown inside of your column. So all you would do is pretty much do the exact same thing, but you would just add a not operator, or the bang operator as you would call it. And then let's go ahead and run that. And this is what you get. Diaporthmy stem canker, along those lines. So let's go ahead and run a really other cool functions. Maybe we want to sort, and so let's sort it by like date, I guess. So we would just use the arrange function, and then we would just plug in our column name, just maybe dates, and yeah, we just sorted it by dates. Where's it? 0, 0, 0, 0, 0, 0, and then 1 over here. Let's say that we want to create a column, right? So it'll be really cool, and let's just go ahead and go back to our original data set where we are working with this. A little bit less columns, and we have some numerical variables over here. So let's go ahead and create a new column, and you would do this this by using the mutate function. So you would run the mutate function, and let's say that you want to create a function that has like longest shell times diameter, or actually let's do rings times height. Yeah, okay, rings times height, and then that would just be rings times height. It's like real easy. And we run that, and then you have an additional function. Let's actually view this so we have better clarity as to what that looks like, and let's just run view. So we have an additional column over here. Maybe we want more than one column, so all you would do is just add a column. And you can run maybe like an addition on, let's say, diameter and height. So diameter and height, so this is going to be the column name, and then that would just be diameter plus height, if I can spell correctly. Yep, there you go. And we have rings times height and diameter height. So that's how you create additional columns to whatever data set you might be working with. So if we want to run maybe more specific, like if else statements, you can easily do that as well. So let's run the pipe function, and then we want to create a new column, and let's just say maybe the abalone is going to be old or not. So we'll just have a old column, and then we will have an if else statement within here. And then since we know that the age of abalone is going to be really related to rings, so let's say I think one ring is 1 year. So maybe an abalone in this case is going to be really old if it's greater than 10. So you just do rings is greater than 10. So if it's going to be true, if it is greater than 10, then let's have a categorical variable, call this old. And if it's less than or equal to 10, then we know that it is going to be young. So let's go ahead and run that, and voila, we have a column. Should be called old. Maybe we should call this age judgment, or judgy. Age judgy. Yeah, and then we have old and young. So greater than 10, old. Less than or equal to 10, young. So that's how you go about filtering for specific observations on that particular data set. So last but not least, maybe we want to have like an aggregate function in order to get some summary statistics. We can do this by running the the pipe function. Real powerful is going to be group by, and then let's say we want to group it by type, so it would be male, female, and I don't know what I stands for abalone. I guess you could put that in the comments down below. And then it will be the summarize function. Really powerful. So maybe we want to have an average. We can average rings by type is going to be the column name, and then we just have the mean of, let's say, rings over here. Also, a really powerful method is that if you have NAs in your data set, you can just add the na.rm function and put that as, like true. And if it's false, then you're going to be incorporating the NAs in your data set, and you might have a few errors along the way. So let's run that, and it'll return a tibble, and this is going to be the group by function. So this is going to be each of the averages of this specific gender, and these are going to be the averages of the rings. And then you can go ahead and maybe even run some additional statistics, like maybe you want to have the sum of the rings by type, and then you just have the sum of the rings, and then incorporate the NARM is equal to true. So there you have it as an additional column, and then you can go ahead and visualize that, or send that over to maybe someone else who might have some use for that. So I hope that you enjoyed this. Make sure you leave a like, make sure you comment as well if you have any questions. Make sure you hit that subscribe button with those notifications on, and I hope to see you in my next video. Thank you guys so much for watching.